Welcome to C and C++ programming under EPG Pathshala. Today we will see module 35, pointers, virtual functions and polymorphism. All these three terms, which are pointers, virtual functions and polymorphism, is very important in C++ programming language. There are some disadvantages with the pointers, so the concept of references has been used in C++. So till now we have used references in C++, but pointers has to be used in case of inheritance and virtual functions. So pointers comes late in case of C++ programming language. Polymorphism is a very important concept of object oriented programming. Polymorphism means many shapes. Depending on the context, a proper shape, one form will be executed at runtime. Polymorphism will be basically divided into two categories. These are compile time polymorphism and runtime polymorphism. The compile time polymorphism will have two forms, that is function overloading and operator overloading. We have already covered function overloading and operator overloading in earlier modules. In this particular module, we are going to see in the details of runtime polymorphism. The runtime polymorphism in C++ is implemented using the concept of virtual functions. In virtual functions, basically the base class function and the derived class function name signature will be same. So function signature is same in base class as well as in derived class. Depending at runtime or the address of the pointer, it will be decided which function has to be called. This is basically runtime polymorphism, and the addresses are resolved at runtime on late binding. That is why it is called as runtime polymorphism. Now let us see in detail what happens in runtime polymorphism. There are some more concepts which we are going to see in detail. These are pure virtual function, abstract classes and so on. So now let us start with our module 35. The memory of computer is planned as a sequential group of bytes. Every byte in the memory of the computer has a unique address. In the same way, each and every variable in the program is accumulated at a unique address. A pointer is a variable that holds the memory address, generally the location of another variable in the memory. The C++ programming language permits to have pointers to objects. The pointers that are pointing to the objects are referred to as object pointers. The polymorphism is the capability of objects to take dissimilar forms. The ability to show the behavior of the variable depending on the condition is a great ability in any programming language. In other units, the polymorphism concept is studied, which is basically the compile time polymorphism, that is function overloading and operator overloading. C++ supports a method identified as virtual function to accomplish the runtime polymorphism. Now let us see the learning objective of this module. We are going to study about the pointers. We will learn about pointers to objects. We will study about pointers to derived classes. We will see the concept of polymorphism. We will learn about virtual functions. We will learn about virtual destructor. We will learn about abstract class and pure virtual function. A pointer is a variable that tries to hold a memory address, generally the location of another variable in memory. Pointers try to provide another approach to contact other data objects. Some of the arithmetic operators that can be performed with the pointers are plus plus, minus minus, plus minus, plus equal to and minus equal to. At every instance, when a pointer is incremented by 1, then it tries to point to the memory location of the next element of the respective base type. The example is, suppose if pointer is a pointer of character data type, then ptr++ will try to increment pointer by 1 byte. On the other hand, if ptr is an integer pointer, then ptr++ will try to increment the value by 4 bytes. Now let us see a simple program to see the usage of arithmetic operations on pointers. We will start with the program. Hash include IOStream using namespace std, integer main. Now we will declare one array here and will initialize that particular array as integer numbers opening and closing square brackets is equal to, in curly braces, the initialization list is 57, 74, 22, 18, 90, curly braces will end and semicolon. Now we will declare the pointer as integer star iptr. We will declare one integer variable as integer I. Now we have declared here one array, one pointer and one integer variable. Now we will display the message on the screen, integer array values are endl. Now we will try to display the integer array using the for loop. For I equal to 0, I less than 5, I plus plus, C out numbers in bracket I endl. Now this particular for loop will display the array as it is on the screen. Now we will give the initial address of this array to the pointer. So our statement will be iptr is equal to numbers. So the starting address of numbers array is given to the integer pointer iptr. Here even if you do not write address operator, it is okay, because the first element of array is nothing but address numbers 0. So only the statement iptr is equal to numbers is nothing but the address of the array first element is assigned to the iptr pointer. Now we will display the values as cout value of iptr is equal to star iptr. We will increment the iptr by 1 as iptr plus plus. Now we will write cout value of ptr plus plus, the contents of iptr as star iptr. Now we are going to decrement the value by 1. So iptr minus minus, cout value of iptr minus minus is star iptr. Now we will increment iptr by 2. So it will be iptr is equal to iptr plus 2. Now we will display the value as value of iptr plus 2, the value of star iptr, return 0 and our program will end. Now when the above code is compiled and executed, it will produce the result as, first it will display the array elements as 57, 74, 22, 18 and 19. Then it will display the value where we assign the iptr as a pointer to the first element of the array numbers. So first value it is going to print is 57 on the screen as star iptr. Then we incremented the pointer value by 1. So it will point to the next element, that is element 1 of numbers array, that is nothing but 74. So next value that will be printed for iptr plus plus will be 74. Then we decremented the value by 1. So the index value 1 the pointer was pointing to, now it will point to index value 0. So value of iptr minus minus will be numbers 0 value, that is nothing but the value 57. Now we have incremented it by 2, iptr equal to iptr plus 2. So it will point to the second value of the array. Currently our pointer is pointing to the 0 index value. Now it will point to the value 2, index value 2, and the index value of numbers array 2 is nothing but 22. So it will display the value as value of iptr plus 2 is 22. Pointer to objects. A pointer can position to objects like the simple data types and arrays. Sometimes there may be situations in the program where the large data has to be collected. So instead of array, we can give the memory at runtime using the keyword new. New operator is used in C++ to create a memory at runtime. It is probable for a pointer to position to a class object. It is also known as an object pointer. The object pointers are of use in creating objects at runtime. It is also possible that a public members of a class can be accessed by using the object pointers. Now let us see a simple program to see the usage of pointers to objects. We will start with our program, hash include iostream, hash include string using namespace std. Now we are going to declare the class of a student here with 2 data members which will be private, and we are going to write the member functions as constructor, one member parameterized constructor, the accept member function and display member function. Now let us define our class of student. Class student, private colon, integer seat number, string, name of student, public colon. Now we are going to write a constructor as student, opening closing bracket, colon seat number 0 comma name of student blank screen opening closing bracket. This is the different method of writing the constructor using the colon initialization list. Now we will write a parameterized constructor as student integer s number string st seat number colon seat number in bracket s number comma name of a student in bracket st opening closing bracket. Our parameterized constructor will end. Now we will write the accept member function as cout enter seat number, will take the seat number as cin seat number, cout enter the name of the student, cin name of the student. Now we will write a display function as void display cout seat number is seat number and name of the student is name of the student and L end of the display function. Now we will write a main program as integer main. We will declare the pointer here as student star pstu is equal to new student. Now instead of declaring the object here, we have declared the student using the new keyword. So we are declaring the pointer to the student class using the new operator. Now we are going to call the member functions using the pointer. Just see the notation here very carefully. It will be in round bracket star pstu which is a pointer dot accept opening closing bracket. So star pstu is a pointer, dot is a membership operator where we are going to call a member function accept. In the same way we are going to call a member function display as star pstu dot display member function. So using the pointers we are going to call a member function of the class. Now we will delete a pointer using delete keyword, delete pstu, return 0 and our program will end. Now when the above code is compiled and executed, it will produce the result as it will display first the message enter seat number. Suppose the seat number entered is 10,001, then it will ask for enter the name of the student. Suppose the name of the student is Deepali, then it will call a display function. It will display the values on the screen as seat number is 10,001 and name of the student is Deepali. Now let us see the program to demonstrate the usage of array of pointers to objects. Now in the first program we have seen a simple object using pointer. Now we are going to see the array of object using the pointer. We will start with our program hash include iostream. Here we are going to define our class as first. So name of the class is class first. Private we are going to declare two data members integer age, integer weight. In public section we are going to declare the constructor, destructor, get age as a member function, get weight as a member function and set age as a member function. So we will start writing our member function. First the constructor first, age equal to 1, weight equal to 5, the destructor which will be empty destructor, then the member function integer get age constant where it is just going to return the age, integer get weight constant which is a member function which is going to return the weight, void set age integer a, age is equal to a. Our class will end here. Now we will start with our main program integer main. Now here in the main program we are going to declare the pointer of objects. So it will be declared as first star f object 10. So 10 object pointers has been declared here, integer I, first star f object pointer. So there is one more pointer which is declared here. Now we will take the values using for loop. For I equal to 0, I less than 10, I plus plus. F object pointer is equal to new first. So we are creating the memory using the keyword new. Now we are going to call it the member function using the pointer f object pointer as f object pointer arrow set age in bracket 2 into I plus 1. So we are calling the member function set age and the parameter is passed. Now f object I is equal to f object pointer. So this first pointer we are assigning it to the array of pointer as location 0. The second pointer will be assigned to the second object pointer and so on. So this loop will be executed for 10 times. Now we will have to display these values back on the screen as for I equal to 0, I less than 10, I plus plus, cout hash I plus 1 colon f object I get age end L. Now we will delete the objects one by one, as for I equal to 0, I less than 10, I plus plus, delete f object I is equal to null. Our for loop will end, return 0, and our main program will end. When the above code is compiled and executed, it will produce the result as #1:1, #2:3, #3:5, #4:7, and so on. The last value will be #10:19. The pointers to derived class. The pointers cannot be used on objects of the base class, but they can also be used on objects of derived class. Since the pointers to the objects of base class are type compatible to the pointers the objects of derived class, therefore it is possible that a distinct pointer variables can be made to point to the objects that belongs to different classes. Even though C++ language permits a pointer of a base class to position to any object that is derived from the base class, but the pointer cannot be used straightforward to access all the members of the derived class. The example is class base class, the class has ended, class derived class public base class, the derived class is ended. Now it is possible to write base class pointer as base class star BP1. We will declare derived class object as derived class DOBJ, which is a derived class object. Now we can point a base class pointer to a derived class object as BP1 is equal to ampersand derived class object DOBJ. Now just notice here, a base class pointer is pointing to a derived class object. Now we can point it in a different way also, as base class star BP2 is equal to new derived class. This is again the second notation which can be used. Slide number 17 and 18. Now let us see a program to implement the usage of pointer to derived class. Now let us see a simple program to implement the usage of pointer to derived class. Hash include IOStream using namespace std. Now we will define our base class using one data member and two member functions. So let us define our base class as class base integer a public colon, we will define our member functions here, void setx integer m, a equal to m. So setx function is going to assign the value to the data member a. Integer get a, return a. So get a function is going to return the value of a to the program. Our class will end. Now we will write a derived class, class derived public base. Here the base class is derived in a public mode. Here also we will write our one data member and two member functions, integer b public set b integer n, b is equal to n. So this function will assign the value to data member b, integer get b, return b, the member function will end and the program will end. Now we will write our main program as integer main. We will declare the base class pointer base star BP. We will declare the base class object as base B1. We will declare the derived class object as derived D1, and we will declare now the base class pointer to a base class object. Now just see these lines very carefully. BP is equal to ampersand base. So here BP is a base class pointer which is assigned to B1, which is a base class ampersand B1. BP arrow set A 20. So it will call a member function of base class set A. Cout base class object A is BP arrow get A endl. It will display the value of A on the screen. Now we are going to assign the base class pointer to a derived class object. So our statement will be BP equal to ampersand D1. BP is a base class pointer, D1 is a derived class object. Now BP arrow set A 40 will assign the value 40 to a variable. D1 dot set B in bracket 16 will assign the value to the variable B of derived class. Cout derived class object is BP arrow get A. Cout derived class object B is D1 dot get B endl, return 0 and our program will end. When the above code is compiled and executed, it will produce the result as base class object A is 20, derived class object A is 40, derived class object B is 16. The next concept that we are going to see is of polymorphism. The polymorphism is a Greek word. It is a combination of two words, poly and morphism. Poly means many and morphism means form. The functionality of this aspect will give you the meaning to its name. The two forms of polymorphism that is supported by C++ language are compile time polymorphism and runtime polymorphism. The process of operator overloading is accomplished by permitting the operators to work on the user defined data types with the same syntax as built-in data types. With the help of function overloading, it is possible to write dissimilar functions by using the same function name but with different argument list. The function would carry out different operations depending on the parameter list that will be matched at compile time. The overloaded member functions are chosen for invoking by matching the parameter list to the actual parameter list. This information is identified to the compiler at compilation time itself, and as a result the choice of the suitable function is prepared at compile time only. It is must to use the scope resolution operator to state the class which invokes the functions with the objects of the derived class. It would be a good idea if a suitable member function could be chosen while the program is running. With the help of inheritance and virtual functions, C++ determines which type of function to call. This is determined at runtime and therefore it is called as runtime polymorphism. In runtime polymorphism, the function is related with a particular class to a large extent later on after the compilation, and as a result it is known as late binding or dynamic binding. Now we will see the concept of virtual functions. The process of late binding, the function call is determined at runtime. Therefore, the compiler decides the object's type at runtime and then it connects the task of function call. Late binding is also called as dynamic binding or runtime binding. A virtual function is a member function that is declared within the base class which is redefined or overridden in the derived class and which informs the compiler to carry out late binding on this function. When the same function name is to be used in the base class and derived class, then the function in base class can be declared as virtual with the help of the virtual keyword prior to the normal declaration. When a function is declared as virtual, it helps in determining which function is to be used at runtime based on the object's type that is pointed to by the base pointer. By making the base pointer to spot to derived objects, it is possible to implement dissimilar versions of the virtual function. The main advantage of virtual keyword is that it tries to verify if a member function of a class can be overridden in its derived classes or no. The advantage of containing virtual function is that it is possible to access the function that is defined in derived class by using the pointer variable of base class. The virtual function tries to apply one interface multiple methods idea that bring about polymorphism. The syntax is virtual return type function name in bracket the parameter list and the complete function definition. Example is virtual void display opening and closing braces. When functions are declared as virtual, the compiler tries to add a data member secretly to the class. This data member is referred as a virtual pointer which is called as VPTR. A table called virtual table which is VTBL holds pointers to all the functions that have been declared as virtual in a class or any other classes that are inherited. At any time a call to a virtual function is made in the C++ program, the compiler tries to generate the code that is used to treat vPointer as a starting address of an array of pointers to functions. The code of the function call basically indexes into this array and calls the function that is located at the index addresses. The binding of the function call at all times needs these dynamic indexing activities which always take place at runtime. If a call to a virtual function is made, a proper care has to be taken that the object that is defined in question as a member of its base class, then the accurate derived class function should be called. As a result, dynamic binding is accomplished with the help of the virtual functions. When a function is made active through the pointer to the base class, then if the function is not defined as virtual, then a static binding is performed at compilation time. The method of the base class will always gets activated. If the function is defined as virtual, then the dynamic binding will be performed at runtime. The method of the write class depending on the address will be activated. Now let us see the characteristics of virtual function. A virtual function must be defined in the class in which it first appears, that is nothing but a base class. It is must that it should be defined as a public member function with the keyword virtual prior to the definition. A virtual function cannot be defined as a static member. A virtual function might possibly be defined as an inline function. A virtual function might be declared as a friend of one more class. Apart from the similar name, the prototypes of the virtual functions in base class and the derived classes must go with accurately in terms of type of parameters and number of arguments. If any variable is found, then the compiler will try to capture it as an overloaded function and the virtual function will drop the status of a virtual function. A constructor function cannot be defined as a virtual function. The destructor function may perhaps be defined as a virtual function. It is possible that the definition of the virtual function in the base class can be overridden by the relevant definitions in the derived classes. In case if in derived class, if the function is not redefined, then the base class definition is only raised. The virtual functions can be inherited to any depth hierarchy. A class that includes the virtual function is referred to as a polymorphic class. Now let us see a program to see the usage of virtual function. It is a simple program which will show you the usage of virtual function. We will start with the program. Hash include IOStream using namespace std. Now here we are going to define two classes. Figure is one class which is a base class and rectangle is a second class which is a derived class. A rectangular class will inherit from a figure class in a public mode. Now let us define our classes as class figure. Protected, we will have two data members as double, width and height. Public, colon, we are going to write now two member function as void set values double d1, double d2, width is equal to d1, height is equal to d2. Now we are going to write a second member function which will be virtual. Virtual is a keyword, double is a return type, area of figure is the name of the function, opening closing bracket, return 0, end of virtual function and end of the class. Now in this particular virtual function we have not written any code, we have just written the return 0 statement. Now we will write a second class which is class rectangle colon public figure. Now here in a public section we will define one member function as double area of figure opening closing bracket and we are going to write a statement inside this function as return width into height. The function will end and the class will end. Now as you can see here, area of figure is a function name where the function signature is same in a base class as well as in derived class. In a base class, this particular function is made as a virtual. Now let us start with our main program. Integer main figure star fp. So fp is a pointer of base class. Rectangle RT, RT is an object of derived class rectangle. Now a base class pointer will point to an address of derived class object. So our statement will be fp is equal to ampersand RT. Now we will call the set values function of a base class as fp arrow set values 5 4. So it is going to call a member function of base class set values where our width will be 5 and our height will be 4. Now we are going to write a statement area, see out area of rectangle is FP arrow area of figure. Now this FP is a pointer. At runtime it is pointing to an address of a derived class. So now area of figure will be called of a derived class. So our code will be return width into height. Width is 5 and height is 4. So return value will be 20, that will be printed on the screen. Return 0 and end of the main program. Now when the above code is compiled and executed, it will produce the result as area of rectangle is 20. Now let us see a program to see the usage of virtual function. Now we will start with the program hash include IOStream using namespace std. Now here we are going to declare 3 classes. Our first class will be a base class, our second class will be a derived 1 class which is going to inherit base class in a public mode, our third class will be derived 2 which will inherit the base class again in a public mode. So we are going to have 3 classes here. We will start with our class definition. Class base public colon integer I1, we will declare the constructor here as base integer x1, I1 is equal to x1. Now we are going to declare the virtual member function here as virtual void my virtual function, and the code will be cout base class version of my virtual function, endl cout I1, end of the virtual function and end of the class. Now we will declare our derived 1 class as class derived 1 colon public base. Now here in a public section we will write the constructor as derived 1 integer x1 base x1. So we are accepting the parameter and we are passing it to a base class constructor, opening closing bracket. Now we are going to write here the function as void my virtual function, opening closing bracket. We are going to display the message inside this function as cout derived 1 class version of my virtual function, endl cout I1 into I1, end of the my virtual function and end of the class declaration. Now we are going to declare our third class as class derived 2 colon public base public colon derived 2 integer x2 colon base x2. This is a constructor which accepts a parameter and it is passing this parameter to a base class, opening closing bracket, and the class will end. Now we will write with our main program. Now this main program has to be read very carefully. First we are declaring the base class pointer as base star b1. We are declaring the object as base b2 in bracket 10. Now we are declaring the derived class object as derived 1 10, derived 2 10. Now b1 is a base class pointer which will point to a base class object. So b1 is equal to ampersand b2. So it is a plain base class pointer is pointing to base class object. Now we are calling a function b1 arrow my virtual function. So it will call the function of my virtual function of a base class. Now b1 is a object, b1 is a pointer which will point to a derived 1 object. So our statement will be b1 is equal to ampersand derived 1. Now we are calling a function b1 arrow my virtual function. Now here the my virtual function of derived 1 class will be executed. Now b1 is a pointer which will point to an object of derived 2 class. So b1 is equal to ampersand derived 2. And now we are calling the function b1 arrow my virtual function and return 0, and our program will end. Now when the above code is compiled and executed, it will produce the result as base class version of my virtual class, the value 10 of I, then derived 1 class version of my virtual function, the value will be 100, and the third will be base class version of my virtual function, the value will be 10. Now here as you can see, derived 2 does not have the function my virtual function. So the b1 pointer has called the base class version of my virtual function. Virtual destructor. The destructor in a base class can be virtual. Every time when the upcasting is performed, then it is must that the destructor of the base class to make virtual for appropriate deactivation of the object when the program is exited. In general, the constructor can never be virtual, but destructors can be virtual. Now, we will see the program to see the usage of upcasting without virtual destructor. We will start with our program hash include IOStream using namespace std. Now, we will declare our base class here, and in base class we are just going to write one destructor. We are going to declare one more derived class where this base class will be inherited in a public mode. In derived class also we are going to write only one destructor. So, let us start with our classes definition. First we will define our base class base1. We will start. In a public section we will write a destructor for base1 as tilde base1, and we will write one message inside this particular destructor as cout base class destructor and end of the destructor. Our class will also end here. Now, we will define the second class as class derived 1 colon public base 1. So, derived 1 class is inheriting the base 1 class in a public mode. Now, we will start with a class definition. We will start in a public section. We will write a destructor for derived 1 as tilde derived 1, and we will write a message the destructor of derived class, and our function will end and our class will end. Now, let us write the main program. We will start with integer main. Now, we are going to declare the pointer of base class which will point to a derived class as base 1 star bp1 is equal to new derived 1. Now, we will delete this particular pointer as delete bp1, return 0, and our main program will end. When this particular program will be compiled and executed, it will produce the result as destructing base 1. Now, we have seen the program where the virtual keyword was not used. Now, let us modify the same program with the virtual keyword and let us see what happens. We will start with our program hash include IOStream using namespace std, class base 1. In a public section, we will declare the destructor as virtual destructor base 1, cout destructing base 1 endl. The destructor function will end and our class will end. Now, you can see here we have just added the keyword virtual in the previous program. Now, we will declare our derived class as class derived 1 colon public base 1 public colon the tilde sign derived 1 which will be a destructor, cout destructing derived 1, end of the destructor, end of the class. So, now we have returned the base class destructor as virtual and we have defined the derived class destructor. Now, let us start with our main program integer main. Now, we will declare the pointer of base class which will point to a derived class object as base 1 star bp1 is equal to new derived 1. Now, we will say delete bp1 and return 0 and our program will end. Now, because we have made in a base class as base class virtual destructor, when the above code is compiled and executed, it will produce the result as destructing derived 1, destructing base 1. So, both the destructor will be called here, the derived class destructor as well as base class destructor. Now, let us see the concept of abstract class and pure virtual function. Abstract class is a class which contains as a minimum of one pure virtual function in it. Abstract classes are mainly used to make available an interface for its subclasses. It is must for the classes that inherit an abstract class to make available the description of the pure virtual function. Otherwise, even the classes will be turn out to be abstract classes. Now, let us see the characteristics of abstract class. It is possible to create the pointer and references of the abstract class, but instantiation of an abstract class cannot be performed. The abstract class may be able to contain normal functions and variables along with the pure virtual function. The abstract classes are mostly used for the process of upcasting so that it is possible for the derived classes to use its interface. It is a must for the classes that inherit an abstract class to execute all pure virtual functions, otherwise they will become abstract also. Abstract class and pure virtual function. A pure virtual function is a function that is declared in a base class, but it does not have definition, but it is defined in the derived class. The pure virtual function begins with the virtual keyword and ends with equal to 0. The syntax is virtual type identifier, the parameter list equal to 0 semicolon. The example is virtual void area opening closing bracket is equal to 0. Now let us see a simple program to perform addition and subtraction operations using the concept of pure virtual function. We will start with our program, hash include iostream using namespace std. Now here we are going to declare 3 classes. The first class will be a base class, the second class will be the addition class which will inherit base class in a public mode, and third class will be subtraction class which will again inherit the base class in a public mode. We will start with definition of the classes. Class base class protected integer n1, integer n2, integer result. In a public colon mode, we will declare our member function as void set integer x1 y1, n1 equal to x1, n2 is equal to x2. Now we will declare our virtual function which will be a pure virtual function as virtual void operation is equal to 0. Now we will declare the third member function as integer get return result, and our class definition will end here. While define the second class as class addition colon public class. In a public mode, we will declare the member function as void operation result is equal to n1 plus n2, and our class will end. Now we will declare class subtraction colon public base class. In a public mode, we will declare our member function as void operation result is equal to n1 minus n2, and our class will end. Now let us start with our main program. We will declare the variables as integer number 1, number 2. Now we are declaring the base class pointer as base class star BCP. We are declaring the object of addition class as addition AOPR. The subtraction object is declared as subtraction SOPR. Now we will display the message to the user, enter 2 numbers. We will take the 2 numbers from the user as CE number 1, number 2. Now our base class pointer will point to a addition object class. So it will be BCP is equal to ampersand A operand, that is addition operand. Now we will call a set member function as BCP arrow set number 1 comma number 2. So our n1 will be number 1, n2 will be number 2. Now we will call BCP arrow operation. We will display the message as cout result of addition is BCP get. Now we will call our base class pointer to point to a subtract class object as BCP equal to ampersand SOPR, BCP arrow set number 1, number 2, BCP arrow operation, and our result will be displayed on the screen as cout result of subtraction is BCP arrow get return 0, and our program will end. Now when the above program is compiled and executed, it will produce the result as enter 2 numbers. Suppose the 2 numbers entered as 23 and 10, then first it will display the message result of addition is 33, and then it will display the message result of subtraction is 13. Pointers try to provide another approach to contact other data objects. A pointer can position to objects like that of simple data types and arrays. The object pointers are of use in creating objects at runtime. The pointers cannot only be used as an objects of the base class, but they can also be used on objects of derived class. The polymorphism is an Greek word which means poly and morphism. The 2 forms of polymorphism that is supported by C++ language are compile time polymorphism and runtime polymorphism. In runtime polymorphism, the functions is related with a particular class to a large extent later on after the compilation, and as a result it is known as late binding or dynamic binding. A virtual function is a member function that is declared within the base class and it is overridden in the derived class, and which informs the compiler to carry out late binding on this function. The virtual function tries to apply the one interface multiple methods idea that brings about polymorphism. A table called virtual table, which is VTBL, holds pointers to all the functions that have been declared as virtual in a class or any other classes that are inherited. If the function is not defined as virtual, then a static binding is performed at compilation time. The method of base class method will always be called. If the function is defined as virtual, then dynamic binding will be performed at runtime. The method of the write class will be activated. A constructor function cannot be defined as virtual function. A destructor function may perhaps be defined as a virtual function. Every time when upcasting is performed, then it is must that the destructor of the base class to make virtual for appropriate calling of the object when the program exits. Abstract class is a class which contains as a minimum of one pure virtual function. A pure virtual function is a function that is declared in a base class, but it does not have definition, but it is defined in the derived class.